Hi class, this is our third online lesson and our second in this series of dynamics. Last time we studied about the formula F equals to ma. The resultant force is mass into acceleration whenever the object is in motion. We'll continue with the same thing as I told you earlier. Throughout this dynamics you will see the same formula coming again and again. However, we are going to study now when more than one particles are connected. So we'll be studying connected particles now. There will be more than one particle object, more than one body in the system now. Okay, let's go ahead. Now before we start, you should know about these two things, thrust and tension. Let us discuss this. See, a thrust, to understand thrust and tension, let us take an example that you have a rod in your hand. Okay, let's take a metal rod in your hand and you're holding it at the two ends of the rod. Now if you push your hand towards the center of the rod, okay, if you're pushing towards the center of the rod, then there will be a force opposing it, this like this, the two arrows here. This is called thrust. However, if you take the same rod, handle it from the two ends, and this time you pull it away from the center, okay, you're pulling it up away from the center, then they will experience a force towards the center. This is called tension. Tension, the force will always direct towards each other. Thrust, the force will always direct away from each other. Remember one thing, a rod can experience both thrust as well as tension depending on the direction in which force is applied. However, a string can never experience a thrust. You cannot hold a string and push it towards the center. It will become slack. So a string will always experience a tension when it is pulled away from the center. Okay, let's go ahead. Now let us take this example. These two objects P and Q are connected with the help of a string here. Okay, the masses are given 20. This is exercise 4E, by the way, in your textbook, question number 2. 20 kg and mkg mass respectively, they are connected, okay, by a light. Again, light, we studied the mathematical assumption. Light means we'll assume the mass is 0. They will ask you in exam, what is a mathematical assumption when you say word light? When you will say the mass is 0. Inextensible rod. So now this rod is inextensible. Again, this inextensible, say if it was extensible, then, or if it was elastic in nature, then the acceleration will not be same, the tension will not be same. So if they ask you what is a mathematical assumption by inextensible, the word inextensible, you should say that the tension and the acceleration will remain constant. Okay, and they are on a smooth horizontal plane. The horizontal force of 60 Newton is applied to Q in the direction towards P, okay, as you see in this diagram, causing the particle to move with the acceleration of 2 meters per second. Now the question says find the mass m of Q. Now see, if I take the full system, and again, because the object is moving in this direction, if I resolve this as positive and use the same formula, the resultant force F equals to ma. Now because I'm taking this direction, all force in this direction will be positive and this force opposite will be negative. So this 60 will be positive, this T will be positive, but this T will be negative. Okay, that is what you will see here, equals to total mass 20 plus m times acceleration. The two T's will cancel out and you can easily find the mass of this particle Q as 10 kg. Now to find T, you can take the particle individually also. You don't have to take the full system every time. Now see, if I only consider at P or I only consider at Q, I'll get the same answer every time. It's up to you. Now remember, when you're assuming the system only at P, then there is only one force here, T, that's it. So F equals to ma, there is only single force at P, T equal to mass into acceleration, 20 into acceleration, you get T 40 Newton. At Q, however, see, at Q there are two forces, one is 60, one is T. Remember, this force is not for particle Q, this is for particle P. So at particle Q you have two forces, 60 and T. So 60 in the same direction, T is opposite, so 60 minus T is mass, now is 10 into acceleration, and you get the same answer, T as 40 Newton. Let's go to the next question. Okay. The question here says two boxes A and B of masses 110 kg, 190 kg respectively sit on a floor of a lift of mass. So the lift of the mass is 1700 kg. Box A from this diagram is on top of box B. The lift is supported by light inextensible, again the same inextensible cable, and it is descending, it is going down. They want us to find the tension, this tension in the cable, this thing here. Okay, and part B, they want us to find the force. Okay, let us first talk about part A, find the tension in the cable. Again, if I take the full system and I take down as positive and the same F equals to ma, the resultant force, there will be a weight, correct? There will be a weight going downwards which will be positive. The total mass will be 1700 plus 110 plus 190, that gives you 200 into gravity. That is the weight going downwards, minus T because it is in the upward direction, that is the resultant force, equal to mass. Again the total mass is 2000 into acceleration is given. You solve, you get tension is 16,000 Newton. Clear? Now let's go to the second part. Now this is a slightly different, slightly new concept for you. Find the force exerted by box B on box A. So the force exerted by box B on box A. Newton's third law, force exerted by box B on box A is the same as the force exerted by box A on box B. So from A to B. So what I'm doing here is, I'm just considering box A. Like in the previous question, we took particle P and Q separate. I'll take particle A here, box A separate. The mass of box A is 110 kg. The weight will act downwards, 110 into 9.8. And let us say this is a reaction force because it is on a surface. And the acceleration 1.8 meter per second square. Again resolving down, this is mass into acceleration equal to force. This side is F equals to ma. Downward is positive, upward is negative, and that gives you 880 Newton. See, this is also called apparent weight. See, when an object is in motion, the gravity, because it is an accelerating object, the gravity is not constant 9.8, so weight will be different. That is why you have an apparent weight here. So the weight keeps on changing because the gravity is changing. Okay, so this reaction force, remember R1, the reaction force is also gives you the apparent weight of the object. So the weight and the force, which is the same force exerted by box B on box A, is, that's why 880 Newton. Let's go to the second now. Now they're asking you to find the force exerted on the floor of the lift, okay, by B on the floor of the lift. Let us take it. Same scenario. I've made the picture here again. This is the lift. Again, if I only take box B separate, box B 190 kg, the weight of box B is 190 g. Now since box A is on top of box B and the apparent weight of A, okay, not 110 g, because it is accelerating object, we have to take the apparent weight of A will be acting on B, which is 880 Newton, and there will be a normal reaction which we have to find now. Same, F equals to ma, this mass into acceleration is the resultant force, and that gives you the reaction is 2400 Newton. Got it? Next. Now see, this is question number 7 from your textbook. I am just drawing the diagram for your help. I want you to solve this question on your own. Okay, next slide. Let us take this question. This is question number 9 from your textbook. Okay, I'll draw this system with the help of, there is a diagram for the system. I want you to take a pause now. Pause your video here. I've drawn the system here for you. Try to solve on your own and then we'll continue. Okay, so let us start. The question says a car of mass 900 kg. Okay, this is the car. Pulls a trailer. So there is a trailer, car is pulling, and all that, the reaction force is 200, 100, everything is written here. Show that the acceleration of the car and the trailer, because they are tied together, accelerating together, the combined acceleration is 0.75 meter per second square. Same thing if I take the full system, okay, the full system, and if I take this as positive, the resultant force is mass into acceleration. So now this 1200 is the positive direction, this T is negative, this 200 is negative because they are opposite, in the opposite direction. This T is positive, this 100 is negative. What you can see here, and again the t will cancel. You will get the acceleration 0.75 meter per second square. For the magnitude, like we did before in that earlier question, we can take the separate particle separate. So I'm considering the trailer here because trailer obviously has only two forces. Again, if I resolve right as positive, resultant force is mass into acceleration t minus 100, and you get the tension 325 Newton. For the third part, let us go to a new slide and take that question separate. Okay, the question is again here. Now the car is moving along the road when the driver sees a set of traffic lights have turned red, and he reduces the force produced by the engine to 0 and applies brake. Now if you see what I made here and what is written here, what is made here, you will see the difference. Obviously, because brake is applied, it should be in the opposite direction. The F should be in this direction, but I wanted to do this way so that you know that even if you take by mistake a wrong direction, there's nothing will happen. It is vector. All that will happen at the end is you will get a negative answer like I got here. That will tell you that the direction that I have chosen was wrong. In other words, not wrong. I mean the object is going in the opposite direction, the negative sign. Same thing, because they said decelerate, the question says the word decelerate, the arrow should be this way. I still took the arrow to be this side. The only thing is, again it's vector. The only thing is I'll get a negative answer for acceleration, which I got here, and that will tell me that the direction is opposite. So it doesn't matter if your arrows are different. Okay, this and this will give you the same answer. Let us take the full system again, taking right as positive, F equals to ma. The scenario will give me F is 1200A plus 300, and now I'm taking for trailer only. Okay, this is the trailer. So and now minus t minus 100. So look, I'm working from this diagram, not from this one. Okay, from this diagram, at trailer t is also opposite and 100 is also opposite direction of my positive sign. So both are negative is 300A. You just simply solve. T is given in the question. Okay, it's here 100 Newton. You substitute, you got acceleration as negative, which means it is decelerating, as simple as that. And now you put in this formula here, we have substitute the value of A. I got A as negative 500 again, which means the direction, it is in the opposite direction. So is it very clear? Let us go to the next one.